All right, we're continuing on with reading portion. The first set of problems, exercise 9.5. This is problem 2B. We're supposed to find the first 5 terms of the Maclaurin series. So n equals 4. And because it's a Maclaurin series, we're expanding around the point x equals 0. And the function is phi of x equals 1 minus x over 1 plus x, or 1 plus x to the negative 1 power. So again, we're going to have the first 5 terms, which are going to be the function itself over 0 factorial, which is 1, plus the first derivative of the function over 1 factorial times x, plus the second derivative of the function over 2 factorial times x squared, plus the third derivative of the function over 3 factorial times x cubed, plus the fourth derivative of the function over 4 factorial times x to the 4th power. Alright, so first of all, let's get the first 4 derivatives. So the first derivative equals the derivative of the first function, which is negative 1, times the second function, which is 1 plus x to the negative 1 power, plus the derivative of the second function, which is negative 1 times 1 plus x to the negative 2 power, times the first function, 1 minus x. And if we evaluate that at x equals 0, we're going to get we're going to get, so 1 plus 0 here times negative 1, so that's negative 1, plus, this is 1, so we have negative 1 times 1, which is also negative 1, so we're going to get negative 2 for the first derivative, evaluated at 0. Alright, let's get the second derivative. So we have 2 terms here that we need to take derivatives of. Let's take the derivative of the first one. It's going to be negative 1 times negative 1, which is going to be 1 times 1 plus x squared, plus negative 1 is outside. We'll leave that out there. Times, and now we have a product. We have to use the product rule. So negative 2 times 1 plus x raised to the power of negative 3 times the second function, plus the first function, 1 plus x raised to the power of negative 2 times the derivative of the second function, which is just negative 1. So what we have here is 1 plus x squared. I'll write it clearly so that we then can use it to take the third derivative easily. Times negative 1 times negative 2 is 2 times 1 plus x raised to the power of negative 3 times 1 minus x, plus negative 1, so it's minus, but then we multiply this negative 1 times this negative 1, so the negatives become a positive, times 1 plus x raised to the power of negative 2. So now we have 3 terms that we're going to have to take a derivative of. It's getting long and messy, but that's what math is about sometimes. It's about being long and messy. Alright, so let's evaluate this at 0. We're going to get, this term is going to be 1 plus 1, so 2 times 1, so this is 2 plus 0 plus 1, so that's plus 1. So that's going to equal 4. So then we're going to have 4 for the second derivative evaluated at 0. So that's going to be this, the second derivative, so this term here. Alright, let's take the third derivative. Alright, let's take the derivative of this term here first, which is 2 times 1 plus x and that's it. Did I do something wrong here? Let me see. Negative 1. This should be to negative 2 power. Okay, so this is negative 2 raised to the negative 3 power. Okay, that's where I went wrong. Okay, so this is that. Plus, the middle term here is again a product. So we need to use the product rule. So it's going to be 2 times, applying the product rule, we're going to have negative 3 times 1 plus x to the negative 4 power times the second function, which is 1 minus x, plus, I'm going to have to continue it on the second line, plus the first function, which is 1 plus x to the negative 3 power, times the derivative of the second function, which is negative 1. So we're done with that. And now we're going to take the derivative of this last term here, plus negative 2 times 1 plus x raised to the negative 3 power. You probably could have combined this term and made it easier, but it's alright. Alright, so what we have left is negative 2, 1 plus x raised to the negative 3 power, this first term here, I'm just simplifying now, plus, so we have negative 3 times 2, so that's negative 6, so that's negative 6 times 1 plus x raised to the negative 4th power times 1 minus x, so I've just simplified this term here, plus 2 times negative 1, so that's going to be minus 2, times 1 plus x raised to the negative 3 power, plus this final term, which is actually a negative 2, has a negative 2 out front, so it'll be negative 2, 1 plus x raised to the negative 3 power. And so plugging in x equals 0, this first term is 1 plus 0 times negative 2, so that's going to be negative 2. And then 1 plus 0 for the second term, so that's 1. And then 1 minus 0, so that's 1, so we're left with negative 6. Minus 1 plus 0, so that's just 1. Minus 2, minus 2. So we're left with minus 14. For the third derivative. Did I do something wrong? 6 I did. 6 and 2. So this is minus 12. Sorry. All right. Let's move on to the fourth derivative. Just leave this term out here that we're going to take the derivative of. I can't promise this won't be on the exam. We'll see. We'll see what'll be on the exam, but there'll definitely be something from this section, without a doubt. It's important that you know how to expand things using Taylor and Maclaurin polynomials. All right, let's take a derivative of the first function. So it's going to be negative 3 times negative 2, so that's 6 times 1 plus x raised to the power of negative 4. Now we have a product of two functions, so we need to use the product rule. So it's going to be minus 6 times, and now we'll take the derivative, negative 4 times 1 plus x raised to the negative 5 power times the second function, 1 minus x, plus the first function, 1 plus x raised to the negative 4th power times the derivative of the second function, which is negative 1. I'm going to move on to the next line here, plus. So we took the derivative of this term. Okay, now we're going to take the derivative of this term here. So that's going to be negative 2 times negative 3, which is 6 times 1 plus x raised to the negative 4th power. And then finally, the last term is also plus 6 times 1 plus x raised to the negative 4th power. Okay, so now we're going to evaluate this function at the value x equals 0. So the first term is going to be 6. The second term, let me see, we have 0, we have 1 and 1, and then we have negative 4 times 6 times negative 6, which is 24. So plus 24. The second term, we have a negative 1 times negative 6, so that's plus 6. And then we have another 6, and then we have another 6. So that's going to be 24 plus 6 plus 4 sixes, which is another 24. So that's going to equal 48. All right. So what we just figured out was this value here. Phi, the fourth derivative of this phi function. Phi is just this Greek symbol, phi. Sorry if I didn't mention that earlier. And it's being evaluated at the value x equals 0. And that gave us 48. Sorry, 48. Okay, so now we have all the numbers we need. So let's start filling in the terms, okay? So this first term here is the original function evaluated at x equals 0. So that's 1 times 1. So it's 1. So we have 1 plus, remember we need the first 5 terms. So we have the first term. Let's look at the second term here. So the first derivative evaluated at x equals 0 we figured out was negative 2 over 1 factorial is just negative 2 times x, so it's minus 2x. Alright, let's look at the third term. So it's the second derivative over 2 factorial. The second derivative evaluated at x0 is 4 over 2 factorial, so that cancels out the 2 in the denominator and reduces the numerator down to 2. 2 times x squared, so plus 2x squared The third term, the third derivative, evaluated at 0, gives us a value of negative 12. Negative 12 over 3 factorial. 3 factorial is 3 times 2 is 6 times 1 is 6. So 12 divided by 6 is 2, so that's negative 2 times the x cubed, so that's minus 2x cubed. And then finally we have the last term. We figured out the fourth derivative evaluated at 0 is 48 divided by 4 factorial. 4 times 3 is 12 times 2 is 24 times 1 is 24. 48 divided by 24 is 2, so we're left with 2x raised to the 4th power. And so it only took us 15 minutes, actually 16 minutes, but we have the first 5 terms of the Maclaurin series of this function, of the original function, expanded around the value x equals 0. And that's it. We are done.